Good day, guys. So I'm the hybrid. So I'll be teaching you today on what is known as what as Redox reaction. Without anything, actually this. You see, the thing is, what do you mean of Redox? Re is from reduction, while us is called from oxidation. So the question now is, what is a redox reaction? Now the thing is, on a normal procedure, we have different kind of chemical reactions. We have different kind of chemical reactions, and you know that there is something called physical reaction and chemical reaction. Physical reaction are those that do not produce a product, that is they are reversible. While chemical reaction are those that will produce a product which are not what irreversible, that is nothing repeats. And under that a type of chemical reaction, what we know as redox reaction. From a redox reaction mostly happen in every equation. In as much there is a reduction, there will be what? Oxidation. So it just come from what? From reduction and what? And oxidation. Now what is let's now explain sometimes what is oxidation. Oxidation. Now in terms of the oxidation is formed from what? From different things. One, in term of what? In term of electron, in term of oxygen, it means gain of what? Of oxygen. I don't know if you are getting me. Now AEG and magnesium react with oxygen, it will give you 2Mg0. Are you getting me? So this magnesium is an oxidizing agent because it attracted oxygen to become this. Now, in terms of hydrogen, it means loss of hydrogen. And I'm going to give a very good example. When H2S react with oxygen, it will produce sulfur and SO2. Sulfur and H20, sorry, sulfur and H20. What does it mean? It means this H2S, but is what? It gain what? Oxygen to become sulfur. Why did H2S is lose what? Oxygen, it lose what? Hydrogen. I don't think you guys are like this H2S, it lose what? Hydrogen to become what? Sulfur. Why this oxygen gain what? Hydrogen to become what? water. You are still going to learn some things about that. You are still going to learn some things. Now, so it means loss of electron and loss of hydrogen is what? Loss of hydrogen is also what? Oxidation. That means this is what? It undergo what? Oxygen because it's able to what? Reduce because it's able to what? Lose hydrogen. You get it? Oxidation means gain of oxygen. Because oxidation also means loss of what? Hydrogen. And these are perfect examples that I can actually take out. We are still going to try something that in terms of what? Okay, because if you also look it in terms of hydrogen, it does not gain hydrogen. Yeah. Only what that gain hydrogen is what? Only to gain oxygen is what? Is this H2. And this H2 gets what? Oxygen to become what? H2 Do you understand? This oxygen, this oxygen is gain what? Hydrogen to become what? H2 Why this H2S lose what? Hydrogen to become this. That is to say, this what? It lose hydrogen, hydrogen. Why this oxygen gain what? The hydrogen. Do you understand? Are we getting some things here? Are we getting some things? Now, now there's also something in terms of electronegativity. In terms of electronegativity, oxidation is also what is also established in that one. In terms of what? In terms of electronegativity. Um, Everything is making sense. Everything is making sense. In terms of electronegativity, everything in terms of electronegativity, we are be able to understand the meaning of oxidation based on two things. Based on what? Gain of oxygen and what? And lose of what? Hydrogen. That's what the common in a common layman. In a common layman. That's it. In a common what? In a common layman. Now, third point. In terms of electronegativity, it is the addition of electronegative elements or electropositive elements. No, no, this is time. Sorry, guys. Sorry. Now, let me give a perfect example. When magnesium react with what? Fluorine, mafani F2. I think we all know that fluorine is an electronegative element. When magnesium react with what? Chlorine, mafani MgCl2. I think we understand that one. No, in terms of electropositivity, it is the what? The removal of electropositive element. e.g. cyanide 6 plus H2O2 equals cyanide 6 plus 2KO8. So, do you understand that? Now, the fifth one is in terms of electron loss. In terms of electron, it is the what? Loss of electron. Do you understand? E.g. when sodium react with chlorine to give out of NaCl2. We can deduce the electron of this one is what? This one lose what? You lose what? Loses 2 electron. Why this one what? Gain what? 2 electron. So what are we now saying now? That means this sodium is what? Undergo what? Oxidation. Sorry guys. That means this sodium what? Will undergo what? Oxidation. Do you understand? Now, if that is all clear, if that is all clear, if that or should I give another example based on that? Should I give another? I don't think we need it. We don't think we need it. So that's a common thing. That's a common thing to do. So from what have I explained, I'm able to talk about oxidation and reduction. And I said, what is oxidation? Oxidation, you can either explain oxidation but in 5 ways. One, in terms of oxygen, in terms of hydrogen, in terms of electronegativity, in terms of electropositivity, and that what use of what electron gain. And the last one, in terms of oxidation number, it is what the gain of oxidation. That is the one that gain that there is an increase in oxidation is what undergo oxidation. Let's use this example again. 2Na plus Cl to NaCl. Oxidation of this is what? Is 0 here. Oxidation of this one is also 0. Oxidation of sodium here is what? Is plus 1. Oxidation of sodium is what? Minus 1. And from 0 to what? To plus 1 is an increase. Okay, so that this sodium is a what? Is an what? Is an oxidation. It's undergo what? Oxidation. Now, let's talk base and reduction. Reduction also is simple. Everything that I've said about oxidation is same thing as reduction. In terms of reduction can also be explained in terms of what oxidation, in terms of what oxygen, hydrogen, electronegative, electropositive. That the exact opposite of oxidation is what is also reduction. Do you understand? The exact same thing of oxidation is also what is also reduction. So now in terms of oxygen, what is reduction? Reduction is the loss of oxygen, gain of hydrogen, loss of electronegative element, removal of electronegative element, addition of what electropositive elements, gain of electron, and what lose of what of oxidation number. Should I still write something down? I'll just make it brief because we have a lot to cover. We have a lot to cover. We are getting there. We are almost there. We are almost there. We are almost there. Now, reduction. It is the what? Gain of what? Of hydrogen. No need to give example on that. It is the what? Loss of electronegative element and gain of electropositive element. It is gain in electron, loss in oxidation. Now, let's now use this example to explain everything. Which perfect example? Let me think about perfect example that we should use. The perfect example for us to use. Now, let's use this one. Now, which perfect example shall I use to explain everything? Now, let's use this. Plus oxygen to give out Na2. Oh, do we make sense? Do we make sense? Do we make sense? Now, let's go for in terms of what. Now let's use sodium. You can look sodium gain of oxygen. That's why this sodium is what. And recall that sodium is what? Sodium is an electropositive element. Just know that all metals are electropositive metal, and majorly all non-metals are electronegative element. Majorly, oxygen is an electronegative element. Now, now this sodium gain with oxygen, which is an electronegative element, to become that means this sodium is what? Is an electronegative element. This sodium is what? Undergo oxidation. Why this oxygen gain with sodium to become this? That means what this one is a what? Is a what? Undergo what? Reduction. But I think there's no problem with that one again. There's no problem again. Now, in terms of oxygen, this sodium gain oxygen to become it. That's how what? Undergo what? Oxidation. Now, in terms of what? Change in oxidation number of this sodium is what? Is 0. Because I will teach you the rule for assign oxidation, because I think that is the next one we are doing. For a free element, the oxidation is always what? 0. It's always what? 0. So this oxidation of sodium is what? Is 0. Oxidation of oxygen is what? Is 0. But oxidation of sodium here is 1. Oxidation of oxygen is what? -2. So that's why from 1 to what? From 0 to 1 is an increase in oxidation number. That's why what? Oxidation. Now let's talk based on what? Based on electron loss. This sodium is +1. He gain electron to become this. This oxygen is what? This oxygen is loses electron. This sodium gain electron, while this oxygen loses electron to become this. That's why it's 2 minus mark 1 b. Ele plus. Do you understand like that? Is there anything you are meant to do again? I think we have understand the summary, the things you are meant to, the things. Another perfect example for, look at this one, plus age. It's still the same thing. This n again also is what? Is there anything that we are meant to do again? Nothing. So let's continue. Let's continue. So now the next thing we are meant to do is what? Is oxidation number. The next thing we are doing is what? Is oxidation number. Because if something gain, something must loses. And I've also tell us some rules. I'll tell us some rules to be able to know oxidation number of a compound of an element, because you cannot cram. You cannot cram everything. So let's just know the basics. If you know the basics, then we are good to go. Let's just know the basics. Now let's talk about what? Oxidation number. Now let's firstly know the rules. The rules. The rules. Now for the oxidation number of a free element or uncombined element is always 1. Is always what? 0. Except if they are ions or if they carry charge. 2. If they are ions or e.g. Al, oxygen, anything you can think of, carbon, anything, hydrogen, they are free. The oxidation number is 0. Now, if they are ion or if they carry charge, their oxidation number is the charge they carry, e.g. Na plus oxidation is what? Is 1. Cl minus oxidation is what? 1. Is plus 1. This one is what? Minus 1. E.g. Al3 plus oxidation number is what? Plus 3. E.g. O2 minus oxidation is what? Minus 2. Do you understand? Now, the third point. The oxidation number of oxygen is minus 2, except in peroxide and superoxide. E.g. in peroxide, like hydrogen, peroxide, is A2O2. The oxidation number is minus 1. Now, the third point. The oxidation number of hydrogen is always an exception in binary compound. What are binary compound? That is compound containing 2 elements, e.g. LIH. Even though everything is making sense, the thing is, this. You should mind me. The ordination number of hydrogen is 1, we know. But it's plus 1 that I want to let you understand. It's not because there is difference between ordination number and valence electron. I don't get what I'm saying. The difference between oxidation number and valence electron. So let's keep that one in mind. So now the oxidation number will only have the charge. The charge, the charge. That's what makes it an oxidation number. Now, the last thing is this. The oxidation number of a compound, the definition of a compound is what is 0. That is, the total oxidation number of a compound is 0, except if the compound is also what, an ion. And if the compound is an ion, then it means that what the oxidation number is going to be what, the number of ions is what is carried. Do we get some things? Are we getting there? Are we getting there? Don't worry. We are going to do some examples. Also. But I think we are learning something. So now, without wasting much of my time, let me be first. Now, the last thing is that the that is the total oxidation number. That is except an air, e.g. Which have an oxidation number of what? Of -2, SO4 2 minus, which have an oxidation of what? -2. Do we understand? Now, let's now treat. Let's have some example. Find the oxidation number of the underlying element. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Now, let's deal with it. With the route that I've given you guys, then you should be able to do this then without issue, without any issue. One, C-A-C-O-3. Now we know that this is the logic. This is the logic. The thing is, you cannot know all the audition number, but there are some logical things that you're supposed to know. You're supposed to know. Before I like something that, let me give me some few minutes. So now, I would like to note some things you're supposed to know. One, note oxidation number of metals. That is, I know that they're in group 1, group 2, group 3 is the number of the group they are. That is to say, the oxidation number of group 1 is +1, e.g. sodium, lithium is assigned the oxidation number of what? Of +1. And 2, all metals are positive oxidation numbers. Note again, oxidation number The same thing of non-metal, that is group 5, group 6, group 7 have the oxidation of the group they are. That is to say, group 7 have oxidation of what? Minus what? Minus 7, abi? But that's not it. That is, I wrote this thing because I know that that's exactly what I'm going to write. No, this is wrong. This is wrong. You cannot use the same logic as that. This is wrong. This is very, very wrong. For non-metal, the idea is what is different from group 5, 6, 7. No, we are getting there. If you can know this rule, then you don't have problem in oxidation number. If you can know this, you don't have difference. The thing is, for group 5, 6, 7, 8, the oxidation number is 8 minus the group they are. 8 minus the group there. That is, for group 5 they are going to have the oxidation of what? Minus 3. For group 7 you have the oxidation of minus 1. For group 6 they have the oxidation of minus 2. Do you understand? I'll write something down. I'll write something down. Now, the third the oxidation number of non-metals which are like group 5, 6, 7 have the oxidation state of 8 minus the group number they are. That is, group 7 element oxidation state is minus 1. Group 6 is minus 2, and the rest. Note again the charge of a non-metal is always negative. Is always always negative. Is there things we are meant to know again? Is there things we are meant to know again? No. No.
And the thing is, the oxidation number of group 4 which are metal age can be 4 and 2. They have change in oxidation number. So if you can get this rule, then you don't have problem. You don't have problem. If you can get this rule, you don't have problem. If you know this rule, then you don't have problem. Now let's go to the example we are given. Now let's solve the example we are given. I'm going to do 5. No, I'll do 8. No, I'll solve everything. It's how the spirit lead me. So now, solution. Solution. The first question is this: CaCO3. We know that calcium. Don't I'll be explaining everything in layman. We know that this is calcium. Calcium is in group 2. Thus, have oxidation number of what? Of +2. Oxygen is in group 6. Thus, have oxidation number of what? Of -2. So therefore, +2 plus C plus 3 times -2 is going to what? 0. So therefore, 2 plus C minus C is equal to 0. C minus 4 is equal to 0. So therefore, C is equal to +4. So the second one is this. So that means the oxidation number of calcium here is what? Is +4. H2SO4. We know that the oxidation of hydrogen is what? Is 1. So my is going to be 2 times 1 plus S plus what? 4 times what? -2 is going to be 0. 2 plus S minus 8 equal to 0. S minus 6 equal to 0. S equal to +6. Now, the third one, SO3 2 minus. That's how to find sulfur. S plus -2 is about 3 equals to -2, because that the what? The calculative oxidation number of a compound is 0, but if it's an ion, it's going to be the what? The ions is going to be the number of discharge. So therefore, S minus 6 is equal to -2. So therefore, mathematically, S equal to -2 plus 6. S equal to +4. That means the oxidation of sulfur here is what? +4. And the oxidation of sulfur here is what? +6. So we cannot see. So not because no sir, when I get the oxidation, you told us that the oxidation number of sulfur is +4. I didn't. Depending on the equation you are given, depending on the equation, it might change. Depending on the compound you are given, it might change. Now let's move to number 4. Number 4. Now what is number 4? Number 4 is it HCl. You should be able to do this one for HCl. You should be able to do it. Please don't what 1 plus dot Cl equal to 0. So that was Cl equal to minus 1. So number 5. CO2 is going to be what C plus dot minus 2 times 2 equal to 0. C minus 4 equal to 0. Then C equal to what? Plus 4. The number 6. Number 6 is what? SO2 S plus what? Minus 2 equal to 0. S minus 4 equal to 0. S plus what? Plus 4. And the number 7 H3PO4. Then going to be what? 1 little bar 3 plus P plus what? Minus 2 equal to 0. 3 plus P minus 8 equal to 0. P minus 5 equal to 0. P equal to plus 5. Number 8 LiH. Li plus what? You know I told you the relation number of hydrogen in binary is what? Is plus, is what? Is minus. Because 2 equal minus 1 equal to 0. L1 minus 1 equal to 0. Li equal to plus 1. Number 9 AlO2. No, I don't think it's AlO3. It's AlCl3. The result for that of aluminum. Al plus dot minus 1 is about 3 equal to 0. Al minus 3 equals to 0. Al equal to plus 3. Then number 10 PO4 2 minus, then it's going to be P plus minus 2 equal to minus 2. P minus 8 equal to minus 2. P equal to minus 2 plus 8. Then P equal to plus 6. So are we clear with this one? Are we clear with it? So if that is well understood, then I don't think we have problem. I don't think we have problem with oxidation number again. So now for the final touch, for the final touch, I think we have talked about oxidation and reduction in base of term of electron. Now what do you say about oxidation? Oxidation means what? Loss of electron. Reduction means what? It means what? Gain of electron. That is to say in a reaction, An element will give another element. That is today. Now let's look at this one. Na plus dot Cl mafani Na plus Cl minus. Now Na loses electron and the electron loss is gained by cloning to become Cl minus. So therefore that is Na is what is reduced to what Na plus and O and what Cl. I think you guys should be able to know is oxidized to Na and Cl is reduced to what to Cl minus. Now the question is, what is an oxidizing agent and reducing agent? Now just know just know just know I think if this is well understood, just know what is now oxidizing agent. What is what oxidizing agent? Oxidizing agent is what they are acceptors of what they are acceptors of electron, while reducing agent are what why the one that loses electron that donate. No, me sef, I'm already getting confused. Don't worry, we are getting there. We are getting there. Now, oxidizing agent, they are agents that accept electron while reducing agent. They are agents that donate electron. Now, let's look at the perfect example again. Na plus Cl equal Na plus Cl minus. Now, Na is oxidized is reduced in no don't let us use because that one will not help us there. It loses electron or donate electron for it to become Na plus, while chlorine accepts the electron donated by chlorine by what by sodium to become Cl minus. Then what am I saying? So therefore, oxidizing agents are those who are reduced, while reducing agents are those that oxidize. Do you get it? That is, those that undergo oxidation are reducing agent. Those that undergo reduction are what? Are oxidizing agent. Do you get it? Do you get it? Do you get it? Because it's perfectly. Do you understand? Now, the final touch of the example. You see? Now, example 2. Justify that the reaction is a redox change. Now, solution. Now, for it to be a redox change, what must happen? That is, oxidation and reduction what must happen. Do you get it? That is, oxidation and reduction must happen. Now, oxidation number of normal Na is 0, while that of hydrogen is also what? 0. That is, there must be a change in oxidation number. Do you get it? There must be what? A change in what? Oxidation number. Let's for that one. There must be what? A change in what? In oxidation number. Now let's firstly use a change in oxidation number and what? A change in loss of electron. A change in what? In electron. Now let's use for that what? Na plus. Now let's know the oxidation number. You know, this is a binary equation. This is the binary compound, and I told you the addition of hydrogen is always one. But when it's in the binary compound, that is when it combines with a metal, the oxidation number is going to change from plus one to minus one. So therefore, let's find the oxidation number of sodium here. It's going to be what? Na plus minus 1 equal to 0. Na equal to 1. So therefore, sodium change from 0 to what? To plus 1, while hydrogen change from what? From 0 to what? To minus 1. That is to say, sodium increase in oxidation number, while hydrogen decrease in oxidation number. Thus, sodium is oxidized while hydrogen is reduced, making sodium be reducing agent. No, don't let us. Okay, don't let us first letter be done. Thus, so therefore, it is a redox reaction. Now,